Thanks everybody for coming out today for this. We're going to be talking about some approaches for unit testing SSIS packages. Based on the responses to the survey, it looks like most of you have at least some familiarity with the process of doing unit testing. We're going to talk a little bit about some of the benefits of that as applied specifically to SSIS, and then talk about some of the ways of unit testing SSIS and some of the tools that are available for doing that. So a little background on me. I'm a SQL Server MVP. I've been working with SQL Server itself since the 6.5 days, so for quite a while now. I've worked on a few books. Prior to getting as deeply into SQL Server as I have, I did a lot of more traditional application development, and the agile approach to application development has influenced a lot of my outlooks on how software should be developed, how IT projects should be run, and unit testing is one of those things that I really liked from the agile processes, and I feel very strongly that it's a very important part of doing solid IT development work. So thus my interest in trying to apply some of that to SSIS. So, and we'll talk a little bit more about that as we go through a few more slides. If you do need to get in touch with me, if you have questions about presentation or any follow-up, I've got a number of points where you can reach me. The probably best way to get hold of me is via the email address jwelch@pragmaticworks.com. I use Twitter on occasion, but I do try to check it at least every couple of days. And you can also reach me at my blog at agilebi.com. Okay, so as I mentioned, we're going to talk a little bit about the basics of unit testing. So those of you who don't have a lot of experience with it, we'll get an introduction. Those of you who do, this will probably be a little bit of recap, but I find that that's sometimes useful, as there's different approaches to unit testing, and this will give you kind of a flavor of the approach that I take with unit testing. We'll talk about why unit test, and if you're already convinced of the need for unit testing, hopefully this will give you some ideas that you can take to others in your organization about why it's important. As I've found, one of the biggest challenges with adopting unit testing or testing in general is convincing people of why it's important to do really robust unit and integration testing. So, we'll talk specifically about unit testing for SSIS, and we'll talk about the challenges that most people run into when they start trying to test their SSIS packages. So testing SSIS packages today, the vast majority of people do what I call the deploy and hope approach. So they write the package, they may run it a couple of times in the BIDS development environment, or SSDT if you're working on SQL 2012. They run it, all the boxes turn green, so they then push it to production and they wait to see if anything breaks. This is unfortunately much more prevalent in SSIS than it probably should be. There are certainly people who take it a step further, but you really get a good bit of it works in the development environment, so that means we're okay to go ahead and push it to production. And a large reason for that is the SSIS environment doesn't necessarily make it easy to test packages. So it kind of encourages the approach of go ahead and run something, hope it works, and don't worry overly much until you're actually out running against real data to see if all the scenarios that you needed to handle were actually handled. So the ease of development in SSIS, the ability to kind of cycle rapidly and run the package and see the green, yellow, red is great from a development standpoint, but it doesn't necessarily encourage great testing approaches up front. So organizations that have taken a step beyond kind of the throw the package out there, see if it works or not, tend to do a lot of manual testing. So again, they may run the package in BIDS. The step here that's above just deploying it and hoping it works, is that they usually have some form of results that are expected numbers that they validate against. So they may run this against a table, and they know, okay, the source table had 150 rows. I'm going to run this through a couple of transforms that are supposed to aggregate some data, and I should come out of this with 50 rows of output data written into my target table. So they tend to do those types of things, but it still tends to be very manual. There's no automation around that. It's, again, running the package in bids, perhaps running it via DT-exec through the command line, but still manually going out and checking the data after the package has been executed to see did it execute successfully and do what we expected it to do. And in this case, there's even, for some people, they may get to the point of actually just running individual tasks within the bids environment to see if that part of it appears to be working properly. And then finally, and this tends to be a fairly small percentage of the SSIS audience in my experience, there are people who are actually doing automated testing. When I do see automated testing, it's typically limited to an execution of the package via either DT-exec or possibly through the API, and some light checks of if we had 100 rows in the source table, did we end up with 100 rows in the target table? There's not a lot of validation of the individual portions of a package. It's really looking at the package as a whole to see, did it move data, and does it look roughly like the data was moved the way we expected it to be moved. So things can be a little bit better than that. When we talk about unit testing and why we want to unit test SSIS, the unit testing approach is really, we want to focus on the smallest unit of a program that we can actually test. So if we were looking at this in the scope of a .NET application, typically the unit you want to test at is a function or method of a class. Looking at it from an SSIS standpoint, we really want to test the smallest executable part of a program, which in SSIS's case is really a task. So that's kind of the level that we want to get to, is to be able to check to make sure this particular task is successfully executing what we expect the task to accomplish. So when we talk about a test case or an individual unit test, we typically look at having some preconditions. This sets up things that the code is designed to expect to have occurred before the code's actually executed. We look at post conditions. What should the state of the application be after the code is executed? And we look at verifying results. Typically, did the code actually do what it was designed to do? Most of the traditional unit testing frameworks are based originally on something that came from Kent Beck, who was a very influential person in the scope of doing unit testing. And he did a framework for this for Smalltalk that undoubtedly built on things before it, but this was kind of the first, I guess, framework that became the basis for many, many other frameworks. And if you're not familiar with Smalltalk, no worries. It was one of the earlier object-oriented languages. So this was in the neighborhood of, I guess, 15 years ago that he worked on this. And the approach that he took became commonly referred to as an xUnit-based framework, and they've done these for a huge variety of languages. The Java has multiple versions of it. .NET has multiple versions of it. There's built-in things within Visual Studio now to support it, as well as NUnit is one of the more popular ones. Even SQL has unit test frameworks that are based off the xUnit approach. Both Datadog SSDT, I believe, has recently added the unit testing process back into the SSDT tool. SQL Unit is another one that's out there. So there's a number of ways of being able to do these types of tests against other technologies. One of the tools that we're going to talk about for testing SSIS is SSIS Unit. This is an open source tool that I wrote that's actually published out on Codeplex that also follows an xUnit based testing approach that you can use to get similar functionality for testing SSIS packages. So some of the common characteristics around any xUnit framework. To really be considered a full xUnit framework, the test execution is automated. So this is not something that you would apply if you're planning on having a QA person actually manually run tests. The goal of the unit testing frameworks is that the tests are automated and you can run them basically on demand at any point in time to verify that the unit test will still pass. The test can be run either individually, so you can run a test in isolation and it should return the same results as if you run the test as part of a larger group of tests. So that means the tests have to be atomic. The tests should not rely on the results of a previous test executing. And a large part of this is you won't, as your test suites build up, you start having a very large number of tests. You need the ability to run smaller subsets of them without having to worry about, well, this test has a prerequisite on another test. Particularly true when we're talking about dealing with data, as we typically are with SSIS, because working with data tends to be orders of magnitude slower than a unit test that's working against purely .NET code, as an example. Those unit tests may take milliseconds to execute. Tests against data tend to take seconds plus, so up into minutes, depending on the size of the data that you're working with. So the ability to run tests in isolation without having a prerequisite requirement on other things becomes really important so that you can test just the portion of the application that you're working on, and you don't have to wait for 6 hours while the entire suite of tests run every time you just want to test one individual portion. Tests consist of basically the setup, which is where all the preconditions that we talked about on the last slide. Setup creates those preconditions. It makes sure that everything is set up for the test to execute successfully. The test itself is the piece that actually executes the unit of code that you're working with, and then verifies assertions, and I'll talk about those in just a second, about what actually happened when that unit of code executed. So when we talk about assertions, assertions are basically true or false statements about the state of the system. So an assertion might be that there are 50 rows of data in a particular table in the database, and that assertion is either true or false. If it's true, it means the assertion passed. The condition that it set it up to check was actually met. So if we're asserting something about the state of our application after code is executed, then that's basically validating that the code did what it was supposed to do. If the assertion is false, it means one of our expectations wasn't met, and thus there's an error, and we need to investigate further to see what the actual error that occurred was. And then finally, after testing, there's a teardown step, and teardown basically is used to get rid of any artifacts that might be left over from the code and restore things to their original state. And we'll talk about some variations on this. Teardown doesn't necessarily have to be for each individual test. It can also be done at a global level as well. So we're going to take a really simple example in Visual Basic of a class, and again, we're not obviously working with Visual Basic, but we want to get some basic ideas on what it looks like to do this against a traditional class. So we have an addition class, and we have a function that's called add, and it takes 2 values, and it returns the result of summing those 2 values together. So if I wanted to create a unit test for this, it might look something like this if I was to do the unit test in VB. So step 1, I'm basically setting up my preconditions. For me to test the results of the add function, I actually need an instance of the addition class. So I create that. That's the setup part of my unit test. Then the actual test, I'm executing the add function and capturing the result. And then basically this if statement is making an assertion. I expect the result of 1 plus 3 to be equal to 4. If that's true, then I report that the result is good. If it's false, I report that the result is bad. And then finally, as part of my teardown, I basically get rid of the reference to the class that I just created, so that next time I run this, I will actually be using a new instance of the class. So a very simple example of how this can be applied in VB. So let's look, before we get into some of the advantages, I'm actually going to switch over to a similar example for SSIS. And let's look at a really basic package. In this case, this has an execute SQL task, which is getting a table count from my database, and it is exporting the products table to a flat file products. So if I wanted to test this package, a equivalent unit test might look like this. Now again, this is using SSIS unit. I'll talk more about SSIS unit in a minute, so don't worry about actually understanding all the information here. But basically, what this is an XML formatted set of values that are equivalent to what we just looked at in VB. This tells me here's what I want to test, here's the setup for the test, here's the actual test execution. In this case, we're going to be testing that get table count task, and then what I expect the results to be. So I don't have to look at this in XML. I can also open it up in an SSIS unit GUI. So again, same information, slightly, well, as you can see, my graphical skills are not top-notch. So the UIs I've put together tend to be functional more so than pretty, but it gives you a basic look at what the test is. So what we're going to do is execute our get table count task, and we are looking to verify that the table count is what we expect. Expected result is 71, and let me go ahead and execute this so we can actually see it run. And you can see in this case, we did our setup, it succeeded, the task succeeded, and the actual result of 71 matched the expected result of 71. So the test case was successful in doing what we expected it to do. So before we go any further with this, I am going to go back to the slides and talk a little bit more, but just wanted to give people kind of a visual of how this actually works with SSIS. So some of the advantages associated with this, with doing unit testing in this fashion, one of the number one things is you catch problems earlier. So ideally with unit testing, you're creating a unit test as you're actually coding the solution. So because the testing is performed at the same time, you're closer to the code and it's not as much work to actually fix problems. I'm sure I have this experience on a pretty regular basis. I'm sure other people do as well, of attempting to do some testing or coding something and then coming back to it after some period of time has passed because somebody reports a defect with it. And that period of time could be 6 months. For me, it could be as short as even a couple of days after I finish something. And it takes me longer to get back in and fix the problem because I basically have to go back in and re-understand what is it that I coded. It's maybe that says something about my memory, but I'm sure there's a lot of people out there in the same boat where we all have so much to do and keep up with that something you worked on 3 months ago, that's basically gone if you have to come back to it that much later. You don't remember. You have to refresh yourself on why is the code doing this? Why is this check here? Is it behaving appropriately? Is it not? Whereas if you're doing your testing as you're actually doing the coding, then you're right there. You know exactly what's going on, and it's a lot easier to fix problems much more quickly when that's happening. Because the tests tend to focus on very small units of code, it becomes a lot easier to actually fix those without having to exert an undue amount of effort. So basically, this is the same concept, but a slightly different application of it. You're working on a smaller chunk of code that you have to understand and keep in your head. So knowing where the problems are occurring is typically a lot easier if you have unit testing. The point about it enables rapid change. I know that for me, and I'm sure there's other people in the same boat, if you have a suite of SSIS packages that you've developed, and those have been sitting out and running for the last 6 months, and there haven't really been any changes, and then a business owner comes in and says, we'd really like to make some updates and changes to those packages. We want to, change the way some of these tables are being populated. That can be honestly a little bit scary, because you're getting ready to change something that's working. If you have a solid suite of tests against those packages, then it becomes much easier to feel comfortable making those changes, because at any point in time I can execute it and verify that the results are actually the results I expect. So as I make changes, I know I'm not breaking something that used to work unless I explicitly expected to break that, and thus I can make some updates to it. So the safety net that it provides there is very valuable. And then also regression testing, again, very, very much tied to the same point. I don't have to worry about breaking existing functionality when I go in to fix a bug. There's certainly a lot of cases that I've seen myself in the past where a bug gets fixed, and then 6 months later the same bug shows up again, and often that's because of what are called regressions, or introducing new functionality that affected another part of the system that may result in an old incorrect behavior showing back up again. So if you have automated tests, then it becomes very easy to execute those tests whenever you need to and verify, hey, all these old problems that we have that we created automated tests for when we introduced the initial fix, we now have coverage to make sure that same issue is not going to show up again. Okay. At this point, I noticed we have quite a few versions, quite a few questions. A couple about the version for SSIS unit. SSIS unit will work against 2012, but the compiled version on the CodePlex site does not support that. You have to actually download the current source and then build it yourself. We should have a new version of SSIS unit published very shortly that you will just be able to download it, though. All the code changes are in. It's just some final testing for it and a few other updates that I'd like to squeeze in before I actually release the next version. There is a question about what version of VS I'm using. I'm actually on using SQL Server 2012 is what I'm actually demonstrating with. So you can see that it does work against 2012. And that is using the SSDT tools which is in the Visual Studio 2010 shell. The testing menu option that you saw, specifically the one under Tools and Run SSIS Unit, this is simply an external tool that I set up. So this should be available in any version of Visual Studio or BIDS that you happen to be using for SSIS development. And all I did was create a reference to the SSIS test runner UI.executable, and this actually adds it to your toolbar inside of Visual Studio so that you can easily run it for whatever the selected item is in your Solution Explorer. So that makes the integration a little bit easier. Okay, is SSIS unit backwards compatible with VS 2008? The answer to that is yes. And let's see, we have a couple other questions. The current version is pretty buggy. If you've reported the issues on the CodePlex site, I will certainly take a look at those and see if I can figure out what's going on with them. In my testing, it's been fairly stable, but it's certainly possible that you're hitting some scenarios that I haven't had the opportunity to test. So, And then one final question, then I'm going to get back to the slides. SSIS unit doesn't handle password protected packages currently. When will this be supported? If there's not already an issue on that on the Codeplex site, please file one, and I will make sure to address that in the near future. Right. Thanks for the questions, Sue. If you have questions, feel free to enter them in, and I will try to stop periodically and address those as we have time. So, okay, switching back to the slides. Okay, so process advantages. One of the advantages of doing your unit testing is to write good unit tests, you have to actually fully understand the requirements of what you're being asked to do. So it's often, when we get requirements from analysts or business users, we often tend to have very high-level requirements, particularly I've found in the data warehousing arena. You get requirements that say, well, we need all the customers populated into a customer dimension. And that means moving this set of data from these sources into this target. What you typically don't get is a lot of information about, here's exceptional data values to look for, here's, if the customer is flagged as the customer was created before 1996, then they fall under this processing path. If they were created after 1996, they fall under a different processing path. Those types of requirements often don't come out until you actually start trying to create unit tests and running against the data that you actually have. And that tends to drive more requirements out as you're actually creating the unit test. Another thing that unit tests really provide that I find a particular benefit is I can read someone's unit test and I can see what they expected the code to actually do. So if I look at a unit test that says I am pulling from this table and I expect at the end of this data flow there to be 71 rows in this target table in the database, then I understand exactly what that unit test expects the results to be and how it expects things to work. If that's not being met, then it gives me a couple of things to go check immediately. One is, well, is the prerequisite data, is the preconditions for the unit test not set up properly? And then two, is the test not executing the way it should be? So the ability to get in and understand what somebody else has written by seeing what they expected a unit of code to do can be very helpful if you have to pick up someone else's work and kind of follow along with that. Continuous integration, this is basically the process of being able to quickly edit packages, check those into a source control system, and then have a build. SSIS builds are a little different than most typical application development builds, but essentially the process of checking that into source control, and then immediately it gets put together with all the other pieces of the system and then actually tested as part of the check-in process. So again, this lets you identify bugs and issues much more rapidly, much closer to the source of introducing those if you're able to do continuous integration. A couple of other good things is you can get quality metrics from your test. The more tests that are passing successfully and the more test coverage you have, the better in general the quality of your software is going to be. And if you want to use test-driven development, then it's pretty much required. So what is test-driven development? This is, again, something that was spearheaded by Kent Beck as a development process where you actually don't even write code until you have tests that say what the code should be doing. So step one in the process is you create a test. Step two, you execute the test and see that it fails, which it should, because at this point you haven't actually implemented any code for the test to call. Then you write the code. You execute the test again. If the code was written properly, it should succeed. And then you start refactoring it. And so refactoring is basically the process of cleaning up the code that you're working on, making it more standardized, conforming to convention, as well as easier to understand and using the appropriate patterns. So you effectively follow the cycle until you're done with an application. Now, in general, it's really not 100% necessary to write a test and then execute it without actually having written any of the code. But you can always fall back to this if you need to break up the work into smaller chunks, which is one of the advantages of test-driven development, is being able to subdivide what you're doing into very small units of work. This is definitely more challenging with SSIS, because with SSIS there's really no concept of being able to write a test case against something that doesn't exist yet. So definitely more of a problem area, and one of those places where we have to kind of bend the rules of test-driven development to make it work correctly with the technology. So, let's see, switching back for just a couple of questions. Let's see, some of these, honestly, I'm going to have to follow up on after this, because if I go through and answer each one of these in the appropriate amount of detail, we'll be doing the webinar for another couple of hours. So let's see, there is, how would you enable testing for SSIS unit for continuous integration? Really, you can use it with, if you have the SSIS unit tool and whatever your choice of continuous integration tool is, you are able to execute that from a command line call, execute the SSIS unit test runners from a command line, or you can actually, there's an API behind it, so you can actually integrate it into an MS test or any unit test as well. And that tends to be the easiest way to integrate that into continuous integration. So I will follow up on most of these other questions probably either at the very end or as a follow-up step after the webinar. So just again due to time. So why do we want to unit test SSIS? Well, my primary reason, I look at SSIS packages as being pretty much a program like any other program you might write using VB or C# or anything else. It's a program because I expect the package to do something of value to me or to the business users that I'm implementing requirements for. I expect it to move data from point A to point B and potentially to do some manipulation of that data along the way. So that you can look at as being basically a program. The package, if you've looked at the XML behind it, the XML is basically the source code for the program. The DTExec you can think of, or the SSIS API, you can think of almost like a compiler. It takes that XML that describes a package and it compiles it into a set of instructions that it then executes to actually do the data movement that you told it about. So when you start looking at it that way, you can see, well, certainly I need to test the package, it being a program, and then we can break down the package into each individual task. And these have a lot of similarity to objects in an object-oriented language because each one of them has a method. Task, we're primarily concerned with the execute method because that's what tells a given task to do what it needs to do. So we pass things in, the task needs to interact with something, and we expect it to do something as a result of that interaction. So if we can get to the point of making sure each task performs as we expect, given the proper preconditions, that helps make sure that the package as a whole also performs as it is expected. One of the things that I am currently working on, and this is mostly there but really not quite ready for prime time, is the ability to actually test not just at the task level but also test individual components of the data flow, which I think will be a vast help in kind of testing more complex data flow scenarios. So unit testing an SSIS package. What do we want to test? Basically anything that can cause the package to fail. At a minimum, for me, this is data flow task and the package as a whole. We want to test tasks that have configurations or expressions on it. And scripts I tend to find are very valuable to test within SSIS. How can we test it? Well, as mentioned earlier, you certainly can do manual tests. I really don't recommend that as it tends to be a tremendous amount of work and people stop doing it after a while. So automated tests using SSIS units is clearly what I'm recommending from this presentation. So again, it follows a traditional xUnit style with a setup, a test, and a teardown. You can contain an individual test into a TestSuite, which can be executed as a unit. You actually have an object model that sits behind all this, an API. So you can write the unit test in XML directly. You can use the API to actually create them programmatically if you happen to prefer working in C# or VB. And you can use what GUI there is to create the test as well. I will warn you, the GUI is fairly limited in terms of its functionality today. Basic structure of a test suite. The test suite as a whole has its own setup and teardown. So this is used for any initialization or cleanup that you need to do for all tests within the suite. These are executed once at the beginning of a test run and once at the end of a test run. Tests themselves, if you have setup and teardown that's common to every test, you can do that at the all test level. These are executed individually for each test, but it's the same code for every single test. And then a test itself has its own unique setup and teardown. It also has the asserts that basically validate what the test was designed to accomplish. So rather than go through all the XML via slideware, let's actually switch over to our environment and talk about this in a little bit more depth. Okay, so we'll format this a bit. So this is the same unit test we were looking at earlier, and it's got a couple of key pieces to it. One of those is the AdventureWorks, the connection list, which in this case refers to the AdventureWorks connection. So what this does is lets me abstract away connection information from having to code in connection strings explicitly in various parts of the test. I can actually just code them here and then reference to the connection list. The package list is the same thing. In this particular case, I'm testing this SSIS unit example package that we looked at earlier, and this is basically showing or allowing me to store one reference to it that I then reference from my test. So in this case, I don't really have any setup or teardown to do around this test. I just want to basically validate this execute SQL task for get table count. This is a very simple operation of just returning the count from the sys tables in AdventureWorks is going to return the value that I expect for it. So I have a name for the test, the package I'm referencing as the SSIS unit example. The task, I'm using the GUID to identify the task. You can also use the task name. Depending on how you create the test, if you create it via the test suite builder, it's always going to use the GUID because that guarantees a unique match for the test. So, and the result of the test, or the task, I expect to be success. You can also put failure if you're basically testing a negative scenario where you expect the task to fail. The assert is contained within the test, so this assert is verifying that the table count is 71, and I have the option to test this assertion before or after I actually execute the associated task. So you can test before to make sure that a precondition has been met, or you can test after, which is the more common scenario, to test values after the results of executing the test. Within the assert, we're actually executing this variable command, and I'll flip back to the slides in just a minute and talk about the different commands that you have, but basically commands within an SSIS unit are the things that you have to actually operate against the package as you're running the test. So a variable command performs an operation that can be a get or set. So either we're retrieving a value from a variable in our package or we're setting a value to a variable in our package. The name of the variable in this case is table count, which is what we're storing the results of our execute SQL task in, and the value is blank because since we're doing a get, we don't actually want to set any value into it. So I've got a couple of questions here. Let's see. What is AdventureWorks? AdventureWorks is a sample database for SQL Server that you can download from Codeplex if you search for AdventureWorks sample database. Let's see, a more complex example than a result of a table count. Yes, I will show one of those in just a minute. And then I have a question about how did we set up the test using the GUI and then link it to the SSIS package. So using the GUI, I can actually come in under package list and pick the path to the package. This is just the XML representation that this GUI is working against. So these are effectively two different ways of viewing exactly the same thing. They're both looking at the SSIS unit test. The GUI is just a visual display of that information. This is linked to the package purely by virtue of the fact that it points to the package in a particular path. And I chose package or file storage to demo this with, as most people tend to run this in the context of the development environment, so you'll want to point to things via the file system. It does have the option to use MSDB and other storage mechanisms. It does not currently work with the 2012 catalog, so if you are trying to do that, that is something that is currently not supported. Okay. So again, just to execute this test really quickly, we're still successful. We expected 71 tables to come back, and that's what we actually got back. If I was to change this so that my expected result is now 75, I'm going to save that and then execute it, and this time we notice we get a red box on our assert because our actual result of 71 did not match the expected result of 75. So again, very simple scenario here, and you can see that this actually did get modified via the UI. Sorry, let me reformat again, and we now have the 75 there. So to look at a more complex example, let's look at product. So this is a little bit more realistic of a package. It sees if a file exists. If the file exists, it copies it to a staging area, creates a target table, truncates the target table. So it creates a table only if it doesn't already exist. It loads values from the file into the target table, and then it deletes the file from the staging. So if we look at the SSIS unit test case for this, you'll notice definitely a bit more complicated in terms of what's in here. Let me look at this one through the GUI because I believe that'll make it a little bit easier to kind of navigate through. So again, we have the reference to the product package. We have a few more tests this time. In this case, we're going to verify product rows. Again, this is a kind of a row count scenario, but in this case, we're actually executing a SQL command, and the SQL commands work with basically scalar results from SQL Server. So you can call any function that returns a scalar result, or you can return basically a select statement like this that returns a single value, and that will successfully return a value that you can use to verify your asserts. In this case, we're doing some cleanup by actually getting rid of the product table after we finish the test. Check for file. This one, again, is using a variable command to verify that the file exists variable got populated properly. The copy file has a few additional options. So for test setup, I want to make sure that prior to copying the file, it doesn't actually exist in my working directory, which in this case is the ctemp folder. So I delete it first. Then the file exists test is executed, and I verify it using a file command, which basically has the exist operation, which returns true or false, and looks for a file in a particular path. And then once again, after the test, I want to basically clean up by once again deleting that file. So I can basically go through each of these steps doing this same type of work. Switching over to the questions for just a second, can you use a different operator than equal? You can. Actually, the language within an assert, oops, sorry, let me actually click on an assert. it actually it supports the use of expressions. So if I was to make this true, then I can actually use a C# compatible expression to do evaluations that might not be straight. This value is equal to the resulting value. So there's some flexibility there. There's certainly some work that could be done to make that a bit easier to work with. So, okay, I'm going to go ahead and run this. I believe that most of these should pass. Actually, I think all of them should pass unless I've done something strange. So again, this is an example of a more complex scenario, but it still functions pretty much the same. So, okay, I think that we will switch back to the slides at this point and hit on just a couple of specific points as we go through this. We talked about tasks, setup, teardown. The commands, again, SQL command lets you get a scalar value from the SQL command and compare that to your expected results. File command can do most of your common file operations like doing a copy, a move, or delete. It can verify whether a file exists or not, line counts of text files, which I find myself testing on a fairly regular basis. Variable commands we talked about. Directory command is basically equivalent to a file command, except it works against directories. And the process command can be used to execute basically any external process and return the return code for it. So this gives you a fair amount of flexibility to run other things in order to verify, anything that's not supported directly by a command within SSIS unit. So, all right, so we did the demonstration already. I'm going to talk about some of the common challenges now. Excuse me. A question here, process command is like using XP command shell. It's similar to that, but it's executed directly from the OS, so it doesn't actually leverage the SQL ability to do XP command shell. It's executed directly from the program where the SSIS unit test is running. So, working with data. So a lot of challenges that people run into with unit testing SSIS are specifically around working with data. Databases are slow. Test data is challenging often to find, and you can run into difficulties. As we said, tests need to be atomic. They need to return themselves to their original state, but that means when we're running against a database, most of our functionality of SSIS involves actually changing the database. So restoring it to its original state it can be a significant challenge. So ideally, we want to run unit tests anytime you change anything. If given this, they have to run fast. If they don't run fast, people stop using them really quickly. So anytime you have unit tests where somebody starts to run them and they leave their desk to go get a soda or coffee or whatever, that's kind of a bad sign. You want unit tests running so quickly that people don't feel the need to get up and do something else while they're executing. Some of the ways you can help address that, make sure you're testing against small sets of data. So primarily unit tests are focused on functionality and not performance. Don't confuse unit testing with load testing. You want to focus on getting the right set of scenarios to verify your functionality, not verify that you can load 1 million rows in less than 15 minutes. That's a different type of testing than unit testing. Testing locally. So what I mean by this is generally you get the best performance and the most workable unit test environment when you work against a local instance of your data in SQL Server. So if you're using SQL Server Development Edition, you can have a local database engine installed. Highly recommend that you do that just purely for performance reasons, if nothing else. But it certainly makes some of the other aspects of running unit tests a lot easier if you can run them against a local instance of SQL Server. So particularly one of those things is that if you and one of your coworkers attempts to run unit tests at the same time, which ideally is the way it should work. Unit tests should be able to be run by whichever developer happens to need to execute them. If you're using a shared SQL Server instance, then those unit tests can conflict with each other, particularly if you're running in a shared database. So using local instances of SQL Server is much preferred. Creation of test data, by far the most consuming part, or time-consuming part of unit testing. I've tried using data generation tools in the past. I don't really recommend this because they generally create relatively random data. So they're great if you need to create a lot of data, and they can even create a lot of data that conforms to particular profiles. But again, unit testing, we're not focused on load testing. We don't need a lot of data. What we need is data that hits specific scenarios. So if we expect a conditional split to be hit within our data flow, we need, at a minimum, 2 records coming in as our source. We need one that's going to hit one side of the conditional split and one that's going to hit the other side of it. If we've got lookups, we may want to test both that a lookup is successful and also what happens if the lookup doesn't find a match in the table that it's looking up from. So that's where random test generators don't often let you specify those types of scenarios for the test data that's created. In most cases, I found it's more effective to actually just create the data specifically for the scenarios that you need. If you can get small sets of data out of production, that's fantastic, but in a lot of cases, again, you have the problem of that's not necessarily testing the scenarios you need to test, it's testing the data that's already out there. And again, if it's not a small set, the performance implications can be problematic. Again, run against local instance of the database. One of the techniques that I use to kind of handle the whole I'm running unit test against the database and thus changing the data in most situations. How do I get back to my original state? SQL Server has a snapshot feature. This is incredibly useful for unit testing. What I actually do is in my overall TestSuite setup, I create a snapshot, and in the TestSuite teardown, I revert back to the version that I had with the snapshot. It's a relatively fast process. It works really well, and I know that my database is always in the same state. Other mechanisms you can use for this outside of snapshots is to use a test database that you back up and restore over your target database each time you run your unit test, but that takes a little bit longer. So. Creating good tests, just a couple of quick tips here. Ideally, at least stub out your test first. If you don't know what you're going to test, sometimes it can be really hard to know what you need to write from a code standpoint. Also, creating your test first can lead you to write the code in different ways to make sure it's easily testable. So that's generally a good thing. If you're going to do unit tests, make sure you test all your conditional logic, conditional splits, error paths on lookups not matching, etc., those types of things. You want to make sure you have tests and data that actually hit those types of things. And negative test cases. You ideally want test cases that verify what happens if there is an error. Does it behave properly or not? And then finally, when you hit a defect in your ETL process or your data integration process, create a test case for it that replicates the defect and verify that now that gives you the ability to easily say, we've definitely fixed the defect when you actually do make the code change, and you know that defect's never going to surface again because now you have a test case that looks for it specifically. Okay, I'm going to summarize real quick, and then we'll see how much time we have left for questions. Again, there's a lot of benefits to unit testing, and integration testing. SSIS unit can also be used at that level as well. One of the things that's always stuck with me, one of the project managers I worked for early in my career asked me why I wasn't creating tests. I said, well, there's not that critical. And he said, if it's not important enough to test, why are you even bothering to build it? Which is a great question. So definitely encourage you to ask that about the things that you're building that you're not testing. Definitely would like you to take away that SSIS can be tested at the task level. It can be a little bit challenging, but it can certainly be done, and you want to make sure you're testing as often as possible, which is why we encourage the automation as much as possible to make it easier to actually accomplish that. Okay, a couple of resources on this. The Test-Driven Development is a great book for general test-driven development. It is focused more on kind of Java and more traditional app dev scenarios, but as far as the concepts, a fantastic book. SSIS Unit, as I mentioned, is located on CodePlex, and you can also go to my blog or reach me at Pragmatic Works with any additional questions.